In this video, we are going to look at probably the most popular clustering algorithm called k-means clustering. So k-means clustering, the point of it is to take our cluster data and then separate it into k disjoint clusters. And these clusters are defined such that they minimize what's called the within cluster sum of squares, but we'll get to that a bit later. You'll see what that means when we discuss a little bit more about k-means convergence. So the point of k-means clustering is to separate the data into k-disjoint clusters. What I mean by disjoint clusters means that one point cannot belong to more than one cluster. And the only parameter that we have to set for this algorithm is the number of clusters. So this is an example of an algorithm where you need to have some notion of how many clusters you want your data to have before you run the algorithm. Now, a little bit later, we're going to discuss how you can select this value of k, because sometimes it's quite obvious how many clusters you have, but many times it's not quite so clear how many clusters you should have. And so we'll discuss a couple techniques a bit later on how to choose this parameter k. So k-means clustering is very popular, very well known, and actually the algorithm itself is quite simple. It's just a couple lines of algorithm code, and the code itself is writing. If you had to write it from scratch, also it's not something that would take you a long time. It's very popular. I mean, it's taught in computer science curriculums very commonly. So knowing this algorithm is kind of the first step to getting more acquainted with clustering. It's kind of the baseline algorithm, then we'll move on to more complicated algorithms a bit later. And then one point of terminology here, you'll often hear something called a cluster center or a centroid, and really that's just a point that represents the cluster. So in the figure that I have here on the bottom right, we have two clusters. We have a red cluster and a blue cluster, and the x is the centroid. In other words, the centroid is really like the average of the x coordinates and the average of the y coordinates, and then that's the point. So you can see in the blue, the average, if I average the x coordinates, that's somewhere going to be in the middle, and if I average the y coordinates, that's going to be somewhere in the middle, and we end up with some centroid that's in the middle of that square. And so that's what I mean by centroid. So that's all we really need to know about k-means. Now we can get to the algorithm. We can actually get to the algorithm. I'm going to go through an example with you so you can kind of see it progress step by step with just some fake data, and then we'll discuss some more interesting things about it, such as convergence, properties. We'll talk a little bit about what convergence is, and then we'll also discuss a bit later how do you select the value of k and whatnot. But we're going to get to that. So the clustering algorithm. The first step to the clustering is you randomly initialize the cluster center. So suppose I have some data that I have two clusters for, like in the previous chart here. I have two clusters, so what I do is I just pick two random points to initialize the clusters. Now, the algorithm doesn't. There are many ways to do this, and we'll discuss a couple different ways a bit later. And so after we randomly initialize our cluster centers, then for each point, we assign it to its nearest cluster using some kind of like metric, like the distance formula, for example, Euclidean distance. And then we update the cluster centroids by taking the mean of the points assigned to it. So after each point is assigned to a centroid, we look at the centroids and see how many points are assigned to this one centroid. And then we just average all the points, and that's going to shift the centroid. We basically keep doing this. After the centroids have shifted, we then reset all of our points and figure out where we assign them to the nearest cluster again, and we just keep doing this until the cluster centroids stop moving, or they move a very small, imperceptible amount. Now, let's actually do an example of this with some data so that you have a better understanding of what I mean by each of these steps. So here is our data, and we want to cluster it, and we're setting k equals 2. There's two clusters. If we look at this data, we can kind of see that, well, yeah, there are two clusters here. So I've just randomly initialized these two clusters. There's red and blue, and just place them somewhere on the plane. So now what I want to do is for each point, I'm going to assign it to the closest cluster. So after I do that, I get something like this. So now I've colored all the points red or blue, depending on if it's closer to the red centroid or closer to the blue centroid. So after I've done this, now I need to update my cluster centroids. So how I do that is I look at all the x, for example, for the blue centroid, I'll look at all the x coordinates and take the average, and that's my new x coordinate for the centroid. I look at all the y coordinates of the points, of all the blue points, and I take the average of those, and that becomes the new y coordinate for my blue centroid. So after I do this, the centroids kind of shift over, and then I reset the colors of all the points, and now I just do the same thing again. So now for each point, I have to figure out which centroid is it close to. So after I do that, I get this assignment, and now I again take the average of the x coordinates and the average of the y coordinates for each cluster, and that becomes the location of my new centroid. And so I shift it over again, and so now it's going to be here. And now let's do another. Now I do this one more time, and you'll see that now, if I try to do another shift, that nothing will. The cluster centroids won't actually move again, because in the previous step you see that the same points are assigned to the same cluster centroids. So in other words, my centroids aren't going to move, and we say that at this point we say that k-means has converged. So this, so I hope that this gives you a bit of an overview of k-means here, as in how do you actually run the algorithm in step. So like I mentioned, convergence, just ignore that big equation, it looks kind of scary, but this is just to illustrate a point here. So convergence means that the cluster centroids either don't move entirely, or they move a very, very small amount, and you usually just set a threshold value. So if they don't move at least this much, then we say they've converged. And the reason that I put this equation up here is just to illustrate the point that mathematically k-means is guaranteed to converge in a finite number of iterations. And by iterations I mean assigning the points to a cluster and then shifting, then assigning the points to a cluster and shifting. In a finite amount of iterations, it is mathematically guaranteed to converge. Now, finite number, that still means that it might take a long time, but it will eventually converge. Now, this convergence theorem of k-means doesn't say anything about converging to the best clustering or converging to the optimal clustering. It just says that it will converge. This is still a useful property to know about k-means, because this might not be true of other algorithms. So one other point that I want to discuss is that k-means is actually quite sensitive to where you initialize the centroids, and there are a couple techniques to do this. So one technique that people like to use is you can just assign a cluster just to be a random data point. So you pick a data point and say, that is my cluster center. Another interesting thing is to choose k points that are the farthest away from each other. So if I have 2 points, I'll choose 2 points that are the farthest away from each other within the bounds of my data, between the bounds of the smallest x coordinate, largest x coordinate, smallest y coordinate, largest y coordinate. And another approach is to repeat k-means many times over and over again. You just run the algorithm over and over again using one of these initializations and just take the average of the clusters. There's another way more advanced approach called k-means plus plus that does all kinds of analysis of variance, but we're not going to get into that. In fact, we don't have to implement it either, because it's usually embedded in many libraries. Okay, so the only thing that remains to talk about is how do you choose a value of k? Well, one other thing to do is just to plot your data, try a couple k values and see which clustering works the best. Another technique that's actually quite popular is called the elbow method. And what you do is you choose some values of k, you run the clustering algorithm, you compute this thing called a within cluster sum of squares. In other words, you take the centroid and each data point assigned to that centroid and compute the sum of the square differences between those guys, and you sum up all that. So for each cluster you get one of those, and then you sum it up for all the clusters, and you plot that on a graph. And you can keep plotting this on a graph for different values of k, and then you pick the elbow of this graph here, and it's not a very clear-cut way as to what value of k you should use. It just gives you kind of an idea of what the range of different k you should choose there. So this is also very popular, and again, there are lots of libraries that can actually just generate this for you. You can do this yourself as well. So this is just a technique that you might want to use to figure out how many values of k you should use. Okay, so that pretty much covers k-means clustering. So I want to talk a little bit about some of the advantages and disadvantages of this, and then later we're going to actually see it run on different kinds of data, and we'll see how well it performs there. So it's widely known and used, very popular. Like I said, it's a fairly simple algorithm actually. You saw it's really only like 4 steps, and in lines of code wise, it's not that long either. Simple algorithm, easy to implement. One big perk is that it's guaranteed to converge. It's pretty nice. Disadvantages of k-means: it's algorithmically pretty slow if you know anything about big O notation. It's not. It takes a long time for it to converge. Another issue is that it might not converge to the best solution. It's guaranteed to converge, but it might not converge to the best solution. And it's not very robust against shapes, against clusters that have various shapes. So for like elongated clusters, for example, it might not perform so well. And we're actually going to see this when we look at some fake data. We'll see how well it performs against elongated data, for example. And the reason for this is because we're using the same parameters for each cluster when we do this. So anyway, that is just a quick overview of k-means clustering. And so now that we have this example, we can go ahead and try to analyze how it performs on different kinds of data sets.